Hey, fellow mathers! Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over 6K worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians! Welcome to the podcast where math is figureoutable. I'm Pam Harris,
And I'm Kim Montague.
and we make the case that mathematizing is not about mimicking steps or rote memorizing facts, but y'all, it's about thinking and reasoning, about creating and using mental relationships. We take the strong stance that not only are algorithms not particularly helpful in teaching, but that mimicking algorithms actually keeps students from being the mathematicians they can be. We answer the question, if not algorithms and step-by-step procedures, then what? And boy howdy, are we going to answer that question better than maybe ever before today.
Absolutely. So last week, we talked a little bit about what we're going to be doing in this rest of this series. And we are going to answer the question, if not algorithms, then what? So we are going to dive in today to addition. And we're going to share what we believe are the major addition strategies that your students need to know.
Students need to own these strategies. And if they do, we can throw any problem at them. It's reasonable to solve without a calculator. And they will have power over solving it. They will have the ability to solve it without having to fuss or fumble or reinvent. They're like, yep, I got relationships to use. Bam. And I can solve that problem confidently, fluidly. We've got students that are adders with the best of them.
Mm-hmm.
Can I say adders? Is that a thing? Adders? Adders?
Sure.
Okay. Anyway. All right. So before we start, well, we're just going to say there are four major addition strategies that we've identified that we want to develop in students. However, there's also sort of a precursor strategy, and we don't usually lump that in. If you've ever heard me say 5, it's probably because I lumped it in. Most of the time when we say 4, we don't lump this precursor strategy in, because research has proven that if we don't force a traditional digit-oriented, column-oriented strategy or algorithm on kids, if we don't force that on kids, then almost all kids will develop partial sums as a strategy all by themselves. In other words, if they're looking at a problem like 48 plus 39, and we're just going to use that as an example today, 48 plus 39, and we don't force kids to line them up and then think about the ones and then borrow and carry and all that stuff. You wouldn't really borrow with addition, but carry and all that stuff. If we don't do that, then students will be thinking about 48 and 39. And as they think about 40, I totally just spit when I said 39. You sound like a 39.
I'm glad I'm not next to you.
Yuck. 48 and 39, kids are thinking about 40 and 30.
Yeah.
And they'll pull those together and get 70. And then they'll say to themselves, okay, what was it? It was 48 and 39. Okay, then they'll think about the 8 and the 9, and they'll pull those together. And then they'll pull that 70 and that 17 together. So that's called partial sums, or sometimes we call it splitting by place value. You kind of split everything by place value, pull the place values together, and then pull all of it together.
Mm-hmm.
So that's kind of a precursor strategy. We would expect that you would do work early, or when you're helping students early in addition, you would do work with students to help them get confident in that sort of partial sum or splitting by place value strategy. When I say early with whole numbers, when you start adding decimals, we would also expect that to show back up. Students are going to be making sense of adding decimals together. They're going to split those decimals up by place value, pull the place value parts together, and then pull everything back together. So that's kind of a precursor strategy. But from there, we don't recommend that you go to a traditional addition algorithm. Instead, we want to develop these 4 strategies. So,
Yeah. Yeah, so you're saying 4, right? So let's
uh-huh,
name them, although they may not mean a whole lot to begin with.
the names, yeah,
Yeah,
mhm.
the names are not as important as building the idea behind them. And so we'll give some examples, but let me name them first. The
Yep.
first is add a friendly number, and then we have add a friendly number over. We have get to a friendly number, and we have give and take. So those are the 4 major addition strategies.
And see how we just tell you those, and instantly, if you don't have experience with those, instantly you're probably like, "What? How's that helpful?" Yeah, it's
Yep.
not. So let's give you experience so you can build some relationships so that then those words tagged on to these ideas, then you're like, "Oh, okay, that's what it means." All
Yeah.
right. So,
Okay. First problem. Ready?
okay.
Or the problem. We're gonna give this example or this problem and give examples of each of those strategies. So your problem is 48 plus 39.
Yep. Yep. 48 plus 39.
How about you pick a strategy?
All right. I'm going to add a friendly number.
Okay.
And we would often think that this might be the first one that you start to develop with kids.
Hmm.
So we would say, well, if you're going to keep one of those add-ins whole, so you're going to keep 48 whole and you're going to add 39, well, like what's friendly? And so I might say, well, I'm going to start with 48 and I'm supposed to add 39. I'm going to add 30. I can think about that. Now, young learners might add 10, 10, and 10. We want to encourage them to do bigger, fewer jumps. So I'm going to think about that 48 and 30, and that's 78. But I still have that 9 left over. And so now that I have that 78, then I'm going to think about adding that 78 and 9. And however I do that is less important, but I might add 2 to get to 80, and then I have 7 left over. And so we're at that 87. So it's all about that kind of first move. And the first
Hmm.
move was
Hmm.
I'm starting with 48 and I'm going to add that friendly 30, and then I'm going to kind of adjust from there.
I was
That's
actually wondering what you were going to say about the 9 because there's a couple of other strategies within that you could do.
yeah, for sure. Let's stay with this add a friendly number. Kim, what if I said 39 plus 48?
Oh, so just the community property there?
Yeah.
Oh,
Yeah.
okay. So in that one, then I would start with 39. And instead of so if I want to add a friendly number, then I would start with 39 and I would add 40 to get to 79. And then I would add the 8 to get to 87.
And you sort of adjust from there. Yeah,
Mm-hmm.
cool.
Yep.
So we gave you a problem that you kind of think about either adding a friendly number starting from either number. Cool.
Mm-hmm.
Nice.
Yeah.
All right, y'all. So that's the add a friendly number strategy.
And can you read it? Let's reiterate that the name comes from that first move. I know you said that. It's the
Mhm.
first move that you make. The reason why we would call it that is because you added a friendly number first.
Yeah, the reason we do that is it's your plan of attack. It's
Yeah.
as you hit the problem. Do you do that very first thing that we talked about, that splitting by place value? Do you say to yourself, "I'm splitting both these numbers up," and then go from there? Well, then
Mhm.
you're splitting by place value using partial sums. But if you don't do that and you keep one add-in whole and you decide to, from that 48, I'm going to add that really friendly 30. Wow,
Mhm.
well then that was your plan of attack. Your plan of attack was keeping one add-in whole and adding that next number, but adding a friendly part of it and then adjusting from there,
Mhm.
adjusting up from there,
Mhm.
adding the rest of it on. Cool.
Yep.
All right. So next one is
I want to
related to
do
it. And I'm so glad I'm going to ask you to do this one, Kim, because I think this might be your fave. Add a friendly number over. What does that
Mm.
mean? So same
Mhm.
problem, 48
Yep.
plus 39. How are you going to add a friendly number, but specifically the over version?
So add a friendly number over. You just described add a friendly number and stayed underneath the total
Mm-hmm.
and added smaller chunks. Add a friendly number over is when you would start with the first addend or start with an addend and then add a little bit too much. So if I was adding 48 plus 39, I would start with 48. And instead of adding 39, I'm going to add 40 because it's really close to that 40. So 48 plus 40 to get to 88. And then I ask myself, or tell myself I went too far. How much too much? I added too much. How much too much? Was one too much? So then I go back one to get to 87. So 48 plus 40 and then back up one to get to 87.
And then that 40 and backup 1 is the 39.
Mm-hmm.
So that's your way of adding the 39 was to add 40 and backup 1.
Yeah.
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 And the reason I sort of kidded you a little bit about it being your favorite is because I think it is your favorite.
Yeah. I love to over
Yeah.
things.
When I met you, I had never conceived of the over strategy. All right, all you listeners who just like look down on me, be nice, be nice. There are lots of us out there that never kind of got outside of the rules. Outside, and when I would listen to Kim, I was like, "How did you know to do that?" And she goes, "Well, 39 is so close to 40. Like it's so pleasant. We can just do that." And similarly, if I were just to give you the other example, you started with 48 and added 39 by adding 40 and subtracting 1. You could also say, I'm going to start at 39
Mm-hmm.
and supposed to add 48. So instead, I'm going to add 50.
Mm-hmm.
And 39 and 50 is what, 89?
Mm-hmm.
But I was only supposed to add 48. I've added 50. So I've added 2 too many. So then I would back up 2 from 89, and that would be 80. Another way of getting to 87. So
You know what I'm doing right now as you're talking?
probably the same thing I am.
Oh.
We should take a
Yes.
picture.
Oh.
I'm drawing number lines on my
I
paper. What are
am
you
too.
doing?
I'm sketching what you're saying. I was just
Absolutely.
thinking that if somebody owns some of these strategies and they're like, yeah, that totally makes sense, they could totally practice modeling.
Oh, nice. Yeah, that
Because
would
I'm
be
just
really good.
drawing while you're talking.
That would be really good. So
Yeah.
let's just be really clear. We're writing it down because I'm not going to speak for you. I'm writing down the number lines to follow what we're saying because that helps me follow what we're saying. Like I'm able to keep track of the relationships better by
Mm-hmm.
putting them down on paper as we're saying them.
Mm-hmm.
I could probably do it in my head, but it's easier for me. I can not have my mental space being taken up by holding onto that because I'm holding onto it on the paper. And then I could be thinking about what we're talking about and actually
Yeah.
investing in the conversation rather than being so worried about the numbers, like just holding the numbers in my head. Yeah. So, hey, if you guys want, if you listeners, if you're interested, you could get some modeling practice in as we're talking about these strategies. Nice.
Yeah.
Nice.
Cool.
All right. So we've done add a friendly number. We've done add a friendly number over. How about get to a friendly number? So Kim, same problem, 48
Okay.
plus 39. How would you do the strategy get to a friendly number?
Okay, so I would start at 48. And then if I want to get to the next friendly number, then I would add 2 from the 39 to get to 50. And since I've already added 2 of the 39, then I would just make one big jump of 37 to get to 87. So I made a jump of 2 and then a jump of 37, and that's where my 39 comes from.
Nice. So instead of adding a friendly number like we were just talking about, you still kept one of the numbers whole,
Mm-hmm.
but your first move wasn't to add a big friendly chunk. Your first
Mm-hmm.
move was to get to a nice friendly number. Like in this case, to get to that nice friendly 50.
Which is really nice because then I can add whatever's left in one big chunk.
Yeah. Now young learners might not right off the bat,
Right.
but we want to help them add that leftover part in one big chunk if they can.
Mm-hmm.
In fact, y'all, I just did some work just yesterday with a group of teachers, and a third grade teacher was really frustrated. She's like, "I don't think this way. I've never been good at math. All the things." And in the middle of we were doing a give and take string, which we're about to do. And this get to a friendly number is the precursor strategy for give and take, because in order to give and take, you have to sort of know, ooh, I'm going to get to that friendly number first. That's kind of a precursor thing. And this particular teacher had gotten to the friendly number. And then I said, well, what's left over? And it was fascinating to me that she was able to make that big jump. She didn't have to make little jumps to add the rest of what was left over.
Mm-hmm.
And I looked at her and I was like, oh, don't you tell me that you're not good at math. You're absolutely good at real math. Like you just skipped a step I would have expected you to have to take in your progression. Bam! Like it was a very rewarding day to watch this teacher just sit up taller and taller through the day and just be so excited. Just be really clear. Perhaps she was never good at fake math, but she's absolutely brilliant at real math. It was really fun.
It's so fun.
Hey, do we need to do get to a friendly number by flipping that problem around? 39 plus
Sure.
48.
Sure.
And y'all, the reason we're doing this isn't that we necessarily want to kill this with students. It's not like, okay, now you better do it another way. I don't want to give that misimpression. It's just if we can kind of do a couple of examples that we hope that will help you get a little bit better of an idea of the relationships we're using.
Yeah.
Do you mind doing it?
No, not at all.
Okay.
So then I would think 39 plus 48.
Mm-hmm.
And I would start at 39. And to get to the next friendly number, I only need one. So one more would get me to 40. And that one is from the 48. So now I just need to add 47. And 40 and 47 is 87.
Nice. And an example of what I just meant about having to add smaller chunks is once you'd added that one, you got to the 40, you said to yourself, I have 47 left. If a kid says, okay, 40 and 47, let's say I can add 40 and 40 to get to 80. How much do I have left? 7. Okay, now I'm going to add the 7. That would be an example of kind of needing to make some more jumps in there. And what I was saying is that teacher yesterday didn't have to do that. She make that whole jump of 47 all at once. Very nice.
Yeah, very cool.
Okay, so far we've added a friendly number. We've added a friendly number over. Now we've just done get to a friendly number. Let's pause here for just a second. We would consider that these 3 strategies, add a friendly number over, and get to a friendly number, need to be developed sort of simultaneously. Like they're on, not in the exact moment, but kind of all throughout the time period that you're developing strategies with students. Sometimes you would work on add a friendly number. Sometimes you would work on add a friendly number over. Sometimes you would work on get to a friendly number. As I say that, you'd probably do add a friendly number over a little bit later.
I almost said
that. You'd start with add a friendly number.
Yeah.
But add a friendly number and get to a friendly number are about on the same level of sophistication. They're about the same difficulty. And so we kind of want to be developing both of those. But then we want to move to the most sophisticated addition strategy. And that is give and take. Dun, dun, dun. So what does give and take look like? All right. Who's doing this one?
You go.
Okay. So same problem, 48 plus 39. If I was going to give and take, then I'm thinking to myself, what could I grab? What could I take from one of the numbers to make one of the other numbers really nice? Ooh, that kind of feels like get to a friendly number. But I simultaneously consider if I need 2 to make 48 really nice, like it's 48 plus 39. I need 2 to make 48 really nice. Can I grab it from the 39? Ooh, yes. And then can I consider that resulting 50 and 37 kind of all at the same time? It's sort of this simultaneous look at it. It might feel like get to a friendly number because get to a friendly number is a bit more sequential. I start at 48. I get to the friendly number. I take a breath. I think about what's left. Then I add what's left, making sense of what's left. It's much more sort of sequential. I kind of do something and then I take stock and then I do something else and I take stock. Give and take is much more about, ooh, I can make that 48 into a 50 and look at, I can get it. I can do it by getting that 2 from the 37 and from the 39 to make 37 and bam, I'm just at 50. Boy, I should stop trying to do this fast. Let me try that again. 48 and 39. I can make that 48 really nice. 50. Oh, and I can get it from that 39. Bam, it'll be 37. And I sort of end up with this 50 and 37 almost simultaneously.
Right.
And I can add that to get the 87.
Yeah, it's like you're looking for a different problem.
Ooh, nicely said. In fact, that is a hallmark of some of the most sophisticated strategies that we're going to outline for each of the operations, is that sometimes a strategy is all about creating an easier problem to solve. Say more about that, Kim.
So I actually was thinking about a different problem, but because I was going to give and take the other way. But as you were talking, I was thinking about how this idea of creating an equivalent problem that looks a little bit different, that's just nicer to solve at the end, so that when you landed with the 50 and 37, they just kind of fell together a little bit easier, right? At that point, I don't know if we've mentioned this yet, but at that point, then I can kind of just like read the numbers left to right. It's a little bit of 50, 87. And so there's no in your head having to do a lot of work at that point because you created a nicer problem.
Yeah, like if we would have started this with, okay, everybody, we're really going to focus on strategies. And here's the example problem, 50 plus 37. Everybody would be like, what? Like it's just 80. It's so just like sitting there as 87. And that's part of our goal, is to use strategies that can create equivalent problems that are easier to solve, that just take less, like, oh yeah, so we can just see 50 plus 37. Well, so Kim, we better have you give and take the other, when you said the other way, what would that look like?
Well, you took 2 from the 39 to give it to the 48 to make 50 and 37. I actually wanted to make the 39 nice. And so I made the problem, I took 1 from the 48 and gave it to the 39 to make 47 and 40. So that was 87 as well.
Again, an equivalent problem that's easier to solve.
Mm-hmm.
Yeah, instead of solving 48 and 39, you decided to solve 47 and 40. And
Yeah.
that is the brilliance and beauty of give and take.
Yeah.
Super cool. All right. We are suggesting that if students own these 4 major strategies, that we can give them any problem to solve that's reasonable to solve that a calculator, and they should be able to solve even cranky decimal addition problems using one of those strategies. Kim, I'm a little aware that we're a little long on this episode already, but I did kind of want to ask you another question.
Sure.
Let's see if we can do it. So if I were to say to you, which of these strategies, if I give you a problem, which of these strategies would you rather use? Like, I don't know, if I said anything plus 99, like 55 plus 99. Let's do 56. 56 plus 99.
56
like if
plus
I said that, do you is there what strategy is your fave for that problem?
Oh, I think a lot of times I go 56 plus 100 is 156 and then back up 1 to 155.
And
So
listeners,
I think I do
the
a lot of,
that's the over strategy, right?
Yep,
That's like
yep.
Kim's fave. What if I would have said 99 plus 56?
Oh, that's brilliant. Yeah, because then at that point, then I feel a little less like going over, and I actually take one from the 56 to give it to the 99 to make 100 plus 55, which is 155.
Yeah. And so Kim and I have discussed that we actually think that for the most part, when we hit an addition problem, we think of a couple things. The first thing that we kind of think about is, can we just add by place value?
Mm-hmm.
So if I give you a problem like 42 and 54, I might think to myself, well, that's just 42, 54. That's just 90. What's left over? 6. So we sort of by place value. Notice that I started with the higher, the tens. I didn't start with the digits, and that nobody thinks about the tiny numbers. Those aren't important. So I think about the 40 and 50, and I was like, that's 90 and 6. So if we can just add by place value, we sort of do that. That's kind of a first shot when we hit an addition problem. It's when we can't. It's when you can't just add by place value. Then you say to yourself, well, all right, which of these 4 strategies? But honestly, after you've built all 4, don't we really kind of lean on either an over strategy or a give and take?
Mm-hmm.
I think for the most part.
Yeah.
Maybe every once in a while there might be a reason that something else kind of pings. But for the most part, I think we would then lean towards either an over strategy or a give and take strategy. Those would be sort of is that fair to say?
Yeah, I think so. Yeah.
Cool.
All right. So we last week shared that there is the probably most important download that you can get. It's fabulous. It is huge. It has all these strategies with examples and models. You can find that download at mathisfigureoutable.com/big. And you're going to want to get that today.
BIG, big, because this is a big thing. We've taken quite a bit of time to create this download where we lay out these strategies. You're going to love it. Teachers, this is for you to learn what the strategies are so you can help develop them in students. Leaders, you could use this with your teachers. This could completely be your professional learning with teachers that you do, where you help teachers develop these strategies so they can then help them develop them with students. This is not a handout that you are to download and print off and give to students. This is not the intent. This is for teacher learning. Teacher learning, not a student resource. We do have other student things that we do sometimes, but this is not that.
Yep.
All right. I hope you guys are liking this. If you like learning what the major strategies are for addition, wait till we get into subtraction next week. You are not going to want to miss next week's episode or the whole series where we attack each operation to talk about what the major strategies for that operation. All right, if you want to learn more mathematics and refine your math teaching so that you and students are mathematizing more and more, then join the Math is Figureoutable movement and help us spread the word that math is figureoutable. Thank you for listening and making math more figureoutable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisforgettable.com/challenge. Join us to make math more and more figure outable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.